What am I doing?
What's
Example
up,
1 or
7th
2?
graders? This is Mrs. Talati and Mrs. Cervantes. She's on call right now. But we are today covering 4.2, which is the constant rate of change. Your essential for, oh my gosh, I can't even talk. Your essential understanding for today is I can identify and represent proportional relationships. So vocab is very, very, very big in this unit, and I want you guys to know that this is kind of like your base lesson for a bunch of algebra graphing that we're going to get into, okay? Whether it's Math 7 or Math 7A, this is critical, okay? So as we go through, I want you to pay close attention how this connects back to rates and unit rates, okay? So when you write this vocab down, I'm not going to add a ton of examples, but I just want you guys to be familiar with what these might look like. So rate of change is a rate that describes how one quantity changes in relation to another quantity, okay? So, for example, as my speed increases, I cover more mileage, okay? So it's, again, talking about two different things in comparison to one another, and it's showing that it's going to go up at a constant rate of change, okay? Then you have proportional relationships, which is a relationship between two quantities in which the ratio of one quantity to the other quantity is constant. You're going to start to see these in the way that we write the equations, the way that we graph the equations, and how we connect it back to the unit rate of change, okay? So again, you're going to start to see how all of these interchange. But what I do want to focus on is that you guys can see, again, that we continue to talk about one quantity to another. This one says the two quantities. You're going to see how this constantly pops up from unit rates in 4.1. Then we have a proportion, which is an equation that states that two ratios are equivalent, okay? So I'm going to give you an example here to where it might tie it together. So let's talk about if I write 6 miles in 2 hours. So again, this is a rate because it's talking about two different quantities. We were talking about miles per hour. Well, if I reduce this down and divide the 6 and the 2 by a 2, I get 3 miles per 1 hour. Right? That's our unit rate. So I went from a rate to a unit rate and talking about miles per hour in the final. So in the equation that goes back to this is what I'll cover in the constant of proportionality and where we're going to start looking at more variables. Okay? Then the last vocab word you have is a constant of proportionality, which is a constant ratio of two variables related to proportionality. This is not going to make sense at this point in the game, but I want you to write this equation because it is something we are going to be constantly, like, you guys are going to have dreams about y equals kx. And then in here, I'm going to say that I'm going to kind of jump the gun a little bit. I'm going to identify that the k represents the constant, and that our k is the change in y over the change in x. Again, won't make a ton of sense yet until we get into the actual tables, graphs, and equations. Okay, so let's take a look at example number 1. I'm going to do a lot of ratio writing in comparison of two ratios. So I want you guys to follow me along on this, okay? This says that Callie earns money by dog sitting. Based on the table is the relationship between the amount Callie earns and the number of days, a proportional relationship. There's a couple different things that I want you guys to do every time you look at this. So we're calling these input and output, okay? And again, I'm kind of front loading you guys for what we're about to get into, but I want you to label this table X and Y. And X is known as the input and Y is known as the output. Okay, so in this case, the more days you work, the more money you're going to make. So I input days, which means I get out more money. Okay, and again, you're going to see how this ties back into a graph. So what I want you guys to do is we're going to write these as rates first. So we're going to write each of the rates. And again, if we go back to the idea that I just wrote this as y equals, or k equals y over x, I'm going to look at comparing my y's over my x's, and you'll see then how they become constant, okay? And I want you to write amount earned, which is our money. I'm going to put this as y compared to the number of days, which is the x, okay? So if you look at my first one, the first one is the very most basic. It's the 16-1. So you work 1 day, you get $16, right? This is, and I'm going to identify this because I want you to keep going back to the idea that these are unit rates. For every day work, they gain $16, okay? So then if we look at these, I'm then going to look at my second rate of change. $32 are earned for 2 days of work. Well, if I reduce these two down, 32 divided by 2 is 16, and 2 divided by 2 is 1. So again, we are identifying that my second rate of change has the equivalent rate of change as my first one, okay? My second one is going to be the 48. So for $48, that was 3 days of work. And you want to check these. You don't want to assume, right? So if I look at these, I'm going to say 48 divided by 3. I get a 1. Look at that. This one gave me also a 16 over 1 unit rate. Then I have $64 for 4 days of work. 64 divided by 4. And again, I'm walking you through all of the steps so you can see that they all will or will not be equivalent at the end, okay? And then I have $80 for 5 days of work. And again, I have the 80 divided by 5 gives me 16 also. Now guys, listen, you don't want to check 1 or 2 and assume the rest. They will try and trick you. They might trick you at 2, or they might try and throw you off at 5. The point is you have to make every unit rate, or every rate of change, I should say, every y over x, make sure that it reduces down to your unit rate. Okay, again, looking at that y over x. So in this case, the rates are all equal. They're all $16 for 1 day of work. So this relationship is proportional. Let's write it. Relationship is proportional. And then, gosh dang, I didn't mean to have this much space taken up. Let's write it up here. Constant rate is $16 per 1 day of work. Okay? So again, we want to take the y over x. I can't emphasize enough that we're taking our y over x to identify what that unit rate is. Okay? Now Cervantes is going to cover the next one that is with a blank table.
Hey you guys, this is Mrs. Cervantes. I'm going to go through example 2 now. So looking at your note taker, 2 pounds of cashews cost $19 and 8 pounds cost $76. They want you to show that the relationship between the number of pounds of cashews and the cost is a proportional relationship. And then write an equation. So there's 2 pieces to this. So we're going to show that it's proportional first, and then we're going to write an equation for the relationship. So if we're looking at our number of pounds, let's use 2, 3, and what other number do I want to use? 2, 3, and 8. Let's do that. So let's do 2 pounds, 3 pounds, and 8 pounds. Okay? And if I know that 2 pounds of cashews is $19, and I'm looking that 8 pounds costs $76, what it's saying is show that the number of pounds and the cost is proportional. So all I have is my 2 pounds and my 8 pounds. I don't have my 3 pounds. So how could I find my 3 pounds? If I'm looking at the table, I could do cost. So you're always going to do your cost divided by your pounds. You want your per 1 pound. So your pounds goes on bottom. Okay. So if I'm looking at that, I could do my 19 divided by 2, which gives me, how many times does 2 go into 19? 9 times is 18. 1 left over gives me 1/2. Well, we're talking money here, so it's 9.5. So I'm going to get rid of that fraction, because if we're talking money, 9.5 is $9.50. Okay? If I'm looking at $76 for 8 pounds, again, your cost goes on top. $76 for 8 pounds. If I do this calculation on the side and do my division, 76 for 8, 8 doesn't fit into 7. I have 0, subtract, I have 7. 8 into 76, oh, well, I'm right back to 8 into 76. 8 times 9 is 72. I have 4, so I add my decimal, bring it up, bring down my 0. 8 into 40 goes 5. And because we're talking money, I'm at 0, that's 40. You would add another 0, bring it down, and that would be $9.50. So if we're looking at our ratio of cost to pounds, it's $9.50 or 9.5 for both the 2 pounds for $19 and 8 pounds for $76. So if I know that my proportion or my proportional relationship is $9.50, so if I'm looking, that means per what? Let's write it, per pound. This will help you guys. So $9.50 per pound. Okay? So now I can compare and say, oh, well, it stays the same. So my ratio of price per pound is still the same no matter how many pounds I get, is a way to think of it. So 1 pound is always going to be $9.50. Now if you're looking at 3 pounds, if I put 3 pounds in, if I know my ratio is $9.50, I could do $9.50 times 3 to find for 3 pounds. I get 15, that's 28, move my decimal 2 times, and I get $28.50. So 3 pounds would be $28.50, okay? So now we found, and it says show that the relationship between them is the same. So we just showed that it's constant. It's called a constant rate of change. So what's my rate of change? So let's write that. Constant rate of change. So my constant rate of change is every 2 pounds, or every pound, not 2, sorry. Every pound costs $9.50. There's different ways to say this. That's just one way to say it. You can say the ratio is $9.50 per pound, okay? If I want to write an equation for this, Ms. Talati went over this in example 1, using your x's and y's. So x is my number of pounds, and y is my total cost. So if I'm looking at this, my total cost, y, would be equal to, well, wouldn't it be the number of pounds times $9.50? So my $9.50 per pound, okay? So this is the number of, x would represent your number of pounds, and y would represent your total cost. So how do you, the second part of this equation, or second part of this problem, wants you to write the equation for the relationship. So what you're really finding is that your rate of change is multiplied by your x, by your variable, your number of pounds for this, the context of this problem, and that gives you y, your total cost. So your equation becomes y equals $9.50 times however many pounds you're looking at, okay? All right, let's look at the additional practice. So you have a table there. Go through number 3 using the table, and go through number 4 using the table. Now look, number 3 goes along with Ms. Talati's example, so example 1, and number 4 goes along, so show the relationship and then write the equation for 2. So 2 things. Show the relationship and then write the equation. This goes along with my example, and your equation will be in the form of y equals something x. You need to figure out what that something is. That something is your constant rate of change, okay? All right, work on this. We will see you tomorrow. Do the best you can on this. Remember, if you have questions, write them at the bottom of the page, and we will see you tomorrow. Have a good night.